Hello, game developers. This is Matt with the Dead Pixel Society, and this is the first episode of a new series that I'm going to call Let's Make. Now, what is Let's Make? I see it as my answer to a common problem I see on various game development forums that you probably visit too, especially the Reddit Game Dev subreddit. A lot of the times you'll see people come on there. They're either brand new game developers, or they want to get into game development, and they really don't have any idea where to start. So they come to us and they're like, "Hey guys, I want to do this. What do I do?" And you can pretty much bet on the top advice always being pick a small, easy game, preferably one that already exists, and implement it. Most of the suggestions you see are like Asteroids, Pac-Man, Space Invaders, Mario, Pong, Tetris. Games along that line. Relatively simple games, older games that have simple gameplay elements and that won't require a huge time investment. Which is great. It's really good, solid advice. But unfortunately, it never goes much further than that. So the person's left saying, okay, I want to make Space Invaders, but what do I do? And Googling for things like that doesn't generally turn out well. You'll find half-finished projects. You'll find vague descriptions. Nothing that actually helps you get into it and get yourself on a good footing. So that's what I want to do. I'm going to do a series of videos where we take a basic game idea, something very simple, we implement it at its simplest version. And then we take that and we start iterating on it. We improve it slowly. We add menus, we add transitions, we add particles, animations, tweening, physics, leaderboards, whatever. We just improve on it and learn as we go. So the first one we're going to be doing is Pong. Now, Pong is a pretty good game to start with. It's really simple gameplay-wise. You have two paddles, a ball, and you have a field. Scoring's pretty simple. It's just if it hits a boundary, you score a point. And the gameplay's infinite. There's really no end state. You just play until you quit. It teaches you dealing with vectors, teaches you basic physics, it teaches you some very basic collision detection and response. It's just a good project to start with, and it's what we're going to start with. And you can do fun things with it too to expand on it. And so that's what we're going to go for. Now, as far as language and library go, I'll be using Java alongside the libgdx library. Now, if you're not familiar with libgdx, got the web page here. It's a Java game development framework. It's built on top of LWJGL, which works with OpenGL. It provides a lot of built-in utilities. It has like a 2D scene graph. It has sprite batches built into it. It handles asset loading. It has garbage-free collections. Just all sorts of great things that help game development be easier and faster for you. And in line with Java, it's also cross-platform. So ideally, you can build your game once and then deploy to Windows, Linux, Mac OS, Android, the web, and they're even working on iOS right now. So all good things, all great things, and that's what we're going to use. Here at the download page, you can do release builds or nightly builds. I tend to go for nightly builds. They're generally just as stable as the release builds, but they're a little bit more cutting edge, and just everything's more up to date. So if there's bug fixes, it's pretty much going to always be in this nightly build. That's what I use. I already have it downloaded, but if you need it, you're going to follow along. grab this, download it, extract it. You'll wind up with something like this. All these wonderful files, all these jars here. These are your library files, and we'll be using those in a second. And as far as IDE goes, I'm using IntelliJ. Most of the tutorials you'll find for libgdx, and even the developers themselves, I believe, recommend using Eclipse. You can use either. Eclipse is a little bit more supported, I think. Setup for that is a little bit more automated. But I haven't had any problems using IntelliJ so far. If you are going to use Eclipse and you want to set up your projects, the libgdx wiki here at code.google.com/p/libgdx/wiki will give you a lot of information under the project setup, running, and debugging. This will show you how to set up your application, run your application, debug everything within Eclipse itself. And there's even a section on IntelliJ if you need that as well. But we'll go ahead and dive right in. We're going to get the project set up in this first video, and then we'll move on to actually making the game in future videos. So we're going to hit create new project. We're going to make a new project from scratch. I already have the directory set up here under Let's Make Pong, and this is already set up as a Mercurial repository. I'll be uploading the source code to a link that I'll put in the description. And you can download the source code, play with it, mess around with it, however you need. You should be able to use it in both Eclipse and IntelliJ, no problem. Project name, Let's Make Pong, is fine. Don't need to change anything else. We can just next through these and finish. And that'll make our project. You open up your project here, and you got a source folder, not much else. So first thing we want to do is make a new directory called libs. And into that we're going to copy everything we need to use externally to get libgdx up and going with our project. Now to do that you need quite a few files here. We want the gdx jar, which is the main bulk of libgdx itself. We want the LW JGL backend. We want the natives for that, and we want the GDX natives. The natives are just parts of a library that have been written in C or C++ to be a little bit faster. No big deal. That's just Mercurial asking if I want to add it to the repository, which I do. So that's added in automatically. And we also want to go in here and add in the sources. That way if we need to look at anything that GDX defines class-wise, we'll be able to open it up in our IDE and take a look at it in case we get lost on our way. So copy those over as well. Now we need to let IntelliJ know that we want to use that library. So we'll open up the module settings here. Go down to libraries. There's nothing here. So we're going to hit the plus sign, make a new Java project library. It's going to ask us where the library classes and sources are located. We'll pick libs that we just made and copied everything over to. If I can click, see them all there. Hit OK. Let's say it's going to automatically add it to our module here, which is what we want. It makes it. That's where the classes and sources are located. We'll go back over here to modules. See dependencies. Libs is in there now. We want to go ahead and check this export box so that when we build the project, it'll export those libraries, and so that it can find them and reference them when it runs. Hit OK. It'll index that, and now libgdx is accessible. Got a little Reddit message there. We'll pop that out of the way. First thing we're going to do is make a package for our project. Now if you're not familiar with Java packages, they're similar to namespaces in other languages. It's just a unique identifier for classes and interfaces to go under. That way they can be uniquely identified from things with the same name. So, say you have a class called player, and it's under your specific domain, your specific package name, and you use a third-party library that also has a class named player, they won't conflict because they're under different package names. So it just helps uniquely identify everything we're doing. So, and the common way to do that in Java is you preface it with com dot your name, a company name, something general. So we'll just do let's make here, and then something specific to your project, and we'll just do Pong. So make that let's make. com.letsmake.pong will be our package name. Make that, it pops up here. And we'll go ahead and make a new Java class, and this will be our main game class. We'll just call that Pong game, and we're in. So as you can see, we're in our let's make Pong package. This is just copyright stuff that the IDE puts in automatically for me. Don't have to worry about that. And then we have our class here, Pong game. Now, for this to actually work with the LWJGL backend, we need to implement something called an application listener. So we can do that in one of two ways. We can either extend the game class that libgdx provides, and that basically builds on the application listener interface and implements that stuff for us. Let's see if we import it and look at it. It's the abstract class game implements the application listener, and it implements all these things like dispose, pause, resume, render, resize, and then adds some screen functionality on top of it. We don't actually need this screen stuff. It's not something we're going to use for the base version of our game. So we're going to skip that, and we're just going to implement application listener itself directly. So we'll get rid of that, and then we'll implement application listener. And I'll just use keyboard shortcuts here. Implement the methods for the interface. We're going to implement them all. There it goes. And so clear out this automatic stuff here. So now we can implement all the various parts of the application listener. Just to go over them briefly, create is called once when the application itself is created. It's good to do initialization things here, things that only need to be done once, like creating a sprite batch or a shape renderer, initializing your first screen, that kind of thing. Resize is called whenever the size of your window changes, and it passes the width and the height as integers into that. That way you can resize your game. If you have UI elements that need to be positioned specifically, you can change those around whenever the size of the window changes. We're not going to worry about that for us. We're going to make our window static so it can't be resized, so we won't have to worry about that. Render is called whenever the application should draw itself. On the desktop, this is called continuously. This is our entry point to the game loop. So every frame, render gets called. Once we get into it, we're going to break this up into two pieces. We're going to make an update method where we can do game logic, and then we'll have a draw method where we actually draw the things. But we'll get to that later. Pause is mostly Android related. On the desktop, it doesn't do anything. I think it's called before dispose. It's called in case you need to do anything there. But pause and resume go together. We won't be worrying about those at all for a desktop application. And dispose is where it's called before the application itself exits. And it's where you dispose of anything that you've loaded that Java doesn't take care of itself. So when you load up a texture, or when you load up a texture, for instance, that's managed by the graphics card itself. So if you don't dispose of the texture manually, it's going to stay on the graphics card and eat up your memory, because Java itself won't know about it won't know to garbage collect it or get rid of it. So anything you load manually that's a native thing, like a texture or a sound, it has to be unloaded manually as well. So we will deal with all those. But first, we want to get the game and a window up and running. So the first thing we need is an entry point into the game, a Java entry point, and that's done like you would with any other Java application. You have a public static void main. You have a string array of arguments, which are command line args. We won't be using those, so we'll be able to ignore those. And this is the method that's called when Java starts up the application. And so from there, we need to invoke the LWJGL backend, right? And that's going to create the window for us. And that's going to call our Pong game class that we just made. And that's going to start up the render loop and everything else. So this is kind of the first domino that gets everything going. Now you can invoke that backend in various ways. We're going to do it using a configuration class. So we'll use this LWJGL application configuration. We'll just call it config. Make a new one here. And this lets you define the things about your window. You can see you can make it resizable or not. You can set the title of the thing. You can set the height, the width, whether it uses OpenGL 2.0, and various other things. So first things first, we'll make it not resizable, so we don't have to worry about dealing with that. We will make the width 1280 and the height 720. That'll give us a 720p window with like a 16:9 aspect ratio. If this is too big for your monitor, when you download the source code and play with it, you can change this to whatever you want. We'll do our best to make the code resolution independent, so it won't be too weird, but something like a 16:9 widescreen size will be good for what we're doing. And then we'll set the title, just so we know what we have open here, to let's make Pong. And I think we want to version this just so we know what version we're playing on. So we'll do a little version string up here. And that'll just be our first version. We'll increment that every time we make a major change to it, beyond the base of the game. There we go. And now we need to invoke that LWJGL backend like I talked about. So we'll make LW application, and it wants a listener, an application listener, which I talked about before. That's what our Pong game class implements. So we're going to pass in a new instance of Pong game, which will satisfy that. And then it has different constructors here. Like you can set up the title and the width and the height and all that in the constructor if you want to. Or you can pass in a configuration class, which is what we did and what we're going to use. So we'll do new Pong game, and then we'll pass in the config. And that'll start up the back end. That'll pass in our application listener, which is Pong game, with the configuration we just set up. And so once we run it, we should get a 1280 by 720 window titled Let's Make Pong, version 0.0.1. And it'll do nothing. It'll just be a black screen. But before we do that, we have to set up a run configuration. This is how you do it here. If you're doing it in Eclipse, it'll be a bit different. I'm very popular on Reddit today, apparently. So we'll go to Edit Configuration. We'll make a new configuration. And since we're working on desktop, we'll do Application. We'll just make this desktop. and it wants the main class. It wants the entry point that we just made in this static void main, and it's in Pong game. It's all good. The rest of this, we don't need to pass in any arguments to it. Working directory is fine. All the defaults are good, so hit OK. Now this pops up here. We got this desktop run configuration. In the future, if we were to make an Android version of this, we can make a Android run configuration, and then we could just select that, hit run, and it would run the same exact code just on our Android, either the emulator or on the phone directly. But desktop, let's hit run, see what we get here. Compile, should be no errors. There's our window, 1280, 720. There's our title and our version. It's rendering right now, calling render over and over and over. It's just not doing anything. But that is the start. We got our project set up, and next time we'll look at splitting this render up into update and draw, and we will start making the game. Alright, thanks for joining me.